Alright guys, today we're doing transformations and symmetry. First one is 9.1 for reflections, and this first slide with A, B, C, and D, just quickly identifying what a reflection looks like. That way we know what in the world we're looking for in the future pages when we have to plot some sort of shape on a coordinate plane and then reflect it across an axis. So let's look at A, reflection, B, reflection, C, and D. And first thing I notice is that when you have a reflection, like in a mirror, you're looking at yourself but just sort of flipped the opposite way. And I'm going to jump right to B just like we did in class and realize that this one is a reflection. We have this shape here just reflected across that middle line, and then it just looks like the same thing just flipped over. We notice that this guy is real close to the line, and so is that guy. That's real important when we're identifying a reflection. Versus A, if we look at A over here, we have that line that goes down the center, why not? And we look at it, we notice that this little jetting out peninsula area is actually far away over here. It's not right next to it. And if we were to follow the same pattern as in B over here, that edge would have to be close. Just like this edge here would have to be close, and it's not. So A is not, B is, C is also. This time that line is just going on a slant like that, and that's no big deal. That's okay with us. Notice we have this straight side here matching up with that straight side there right next to it, and we have the rounded side far away, and the rounded side is far away. So this one's just turned a little bit. If we go to C, yeah, let's draw that line straight down. C is not also. We notice that these ends of our star here are definitely different, and these would have to match, and they don't match. So switching to the second slide, now we're getting into looking at, what does it look like when it's graphed on a coordinate plane? And these are just some real easy coordinate planes with just 1 point each, and we're noticing that this would be the original, P. Alright, point P, it's at X and Y. And we look at the second one that's been reflected, and it's just from this distance high and this distance below, we notice there's this prime, this P prime, that's all about it. And we also take care to notice, here's the actual points. They're listed, and we can see how they change. We start off with X and Y, and we end up with our prime as X and then negative Y. So that's going to come in handy in a little bit, and we'll realize what changes about each of these guys. Same thing over here. This guy is across the Y-axis this time, and we notice that's the Y-axis, that's right. So we start off with P, X, and Y, and we end up with P prime. That's our second one. Whenever we write it as a single prime. And we notice the change again here would be X and Y. Well, now our X is negative. That's going to be real important in a minute. Third, Y equals X. Across the line, Y equals X. Totally new to us, not something we're used to. That's just a line that goes like this on a slant. And that's fine. We just still start off with our X and Y, and we end up with our P prime. But notice this time, if we look at what changes, we start off with X and Y, and then we end up with Y and X. We actually flip-flop those numbers. No changing of the negatives, though. Have to be real careful with that when we're doing Y equals X. No problem. Okay, here's our first example. And outside of graphing the points, that would be the first thing you all have to do. I took the liberties of graphing the points for us so we could save some time. Second thing we have to realize here is which axis are we reflecting across? Are we flipping across? That word is flipping. And it says here the x-axis. So we all know this is the x-axis, and our shape should be flipping across that axis. The easy way of doing it first, we're just going to count. Counting is great and easy. So we're going to look at our z, and we're going to realize that our z is 2 places above our x-axis. So then we're going to go down to 1, 2, and we're going to put a dot, our point, right there. And we're going to label it Z prime. Any new points have to be labeled with that prime. Now we're going to do the same thing for x, and we realize our x is 1 place below the x-axis, so we're going to put our point, 1 place above the x-axis, and we're going to label it x prime. Same thing with y. It is down 1, 2, 3, so we're going to go up 1, 2, 3 places. And we're going to label it y prime. And then we're going to connect the dots, make our triangle, and aside from my ugly marks, it looks exactly the same as our other triangle, just flipped along the x-axis. Now, next step always is to come up with our new points. So we have to look at our new x, y, and z and come up with the new points. And so currently we have x prime, right? That's our new x. And it would be at what? I'm going to show you here, right? It's going to be at 2, 1, right? 2 to the right, up 1. So our new points would be 2, 1. Our new y prime, going to be at negative 1, 2, 3, 4. Negative 4, 1, 2, 3, up. Positive 3. Negative 4, positive 3. And then last but not least, our z prime is going to be at 3, negative 2. 3 and negative 2. That's the easy way of doing it. Just recognize which axis we're asking you to flip over, and then counting how many spaces above and going down, or how many spaces down and going up, and moving it. There is a rule we should also all be aware of, and that was on a previous slide. And the rule, very simply, right, we take our x and our y, get a green here, we take our x and our y, and we end up with x and negative y. And it looks like we're just changing the sign of the y. And I like to call this chapter a chapter, it's the opposite chapter. Whatever we're asking you to do, you sort of do the opposite. We're asking you to reflect across the x-axis, so you're changing the sign of the y. And the same thing holds true in the next slide when we reflect across the y-axis. So if we follow the rule and we write our new points, and we're just going to use the points this time, no graph, no plotting, just going to follow our new rule. I'll put the rule here up so we can see it too. We have x prime 2, positive 1, right? We took the y and just changed the sign right here. Negative 1, positive 1. We're going to do the same thing for our y. Y prime starts at negative 4 and becomes positive 3 over there. And the same thing for our z. Z prime 3 and negative 2. And notice again, we only changed the y values. Here we're going across the y-axis this time. So we're going to recognize that this is the y-axis, and we're going to count how many spaces we are to the right, and then do the same thing to the left, or vice versa, depending on where our points are. So our first one that I'll mess with is z. Z looks like it is 1, 2, 3, 4 places this way, so we're going to go 1, 2, 3, 4 places that way. Put our point right there, label that guy z prime. Next one is x. Label that guy x prime. Same thing with y. Y prime. Connect the dots. And you see our picture is essentially exactly the same, just flipped over the y-axis. If we're following the rule, this is a new rule, very similar to the old rule. We start off with x and y, but as you probably guessed, we're going to end up with negative x and y. And yes, doing the opposite. Y-axis, changing the sign of the x. So our new points would be, let's move that guy and just use that rule to come up with our new points. And our new points would be x prime, don't forget the prime, negative 1, negative 1, changing just the x, y prime, negative 1, negative 4, not changing that one, and z prime, negative 4, and 0. Now the last one. Across a given line, y equals x. And unfortunately, there is no easy way to do this one. We cannot just count this many spaces over and this many spaces up. Technically, this line, y equals x, looks like this on our coordinate plane. So it's not easy just to count over and count up like it would be for the other two. This one we have to know the rule. We actually have to write the rule and know the rule. And the rule in this case would be we start off with x and y, and we end up with y and x. And yeah, we just flip the numbers. They are that easy to do. So let's do that one first. It'd be first thing is to get our points, then plot our picture, guys. So we're going to get our points first using that rule. Let's see here. First thing, remember r prime. And we're going to flip those two guys, so it looks like we have 2 here and -2 there. I hate that one. It's a poor example. But the second one makes more sense, right? S prime, and now we have 0 and 5. Just flipping those two. Erase a little bit of that guy. Next guy we have is T prime, and we have -1 and 3. So hopefully everyone can see how all I did was just flip the two numbers. This one went over there, that one went over there. This 0 and the 5 flipped right here, and the -1 and the 3. And notice, and I want to write this down, no signs change. Alright, a lot of us like to change the signs, so no signs change. Now you have to plot your points in. So we have r prime, 2, -2, 2, -2, r prime, right there. S prime, 0, left and right first, then up 5. We end up way up here, S prime. And T, -1 and 3, puts us over here for our T prime. And then just like the others, you connect the dots. You can see our picture sort of flipped right along this axis right here. And that's the axis y equals x.